Hello guys, so we are going to continue discussion with respect to machine learning, and this series that we are probably going to discuss, like coming 4 to 5 videos, will be on feature engineering techniques, right? So the first thing that we are going to discuss is that how to handle missing values. Now it is very much important that to just understand and think, like whenever you are trying to solve a data science project, or it can be a deep learning project or machine learning project as such, the first thing that is required is specifically data. And always remember that, guys, in a real world scenario, when you're working for companies and all, you will be getting a lot of messy data. The raw data, it'll be a bad data, it'll be having a lot of missing values. So in this video, I'm going to talk about all the techniques that we can probably perform to handle the missing values. Okay. Now, why does missing value actually occur in a data set? Let's say I'll give you an example. I have given a survey form to fill to some population or some sample. I'll not say population, but at least for some sample of people. Now, let's say if somebody is not comfortable in filling that survey, right? So they'll just keep that field empty, right? So because of that, you can just see that when that data set is basically created, there will be getting a missing value. So this is just one of the reason, right? So in short, whenever we talk about missing values occurs in the data set when some of the information is not stored for a variable. And there are three mechanisms why specifically missing values happens. And we'll discuss about that. And then we'll go and do a lot of examples. I'll write the code in front of you to show you that how we can probably handle missing values. So the first mechanism why missing values occurs, which is called as missing completely at random, which is also called as MCAR. Now, missing completely at random is a type of missing data mechanism in which the probability of being missing is unrelated to both the observed and the missing data. That basically means missing completely at random basically means that the data, if it is present missing, right, there is no such reason as such, right? There is no such reason, right? It is just available, right? Some data is missed. It may be an error from the data entry operator, or it may be an error from any machine. Probably they are not able to create that particular data. No such specific reason. So in other words, if the data is MCAR, the missing values are randomly distributed through the data set, and there is no systematic reason for why they are missing. Let me show you an example. Like over here, in a survey about prevalence of certain disease, the missing data might be MCR because if the survey participant with missing values for certain questions was selected, right? So probably, the survey people, they have missed some data to fill, right? Knowingly or unknowingly. I'll not say knowingly, but at least unknowingly, right? There is no such specific reason. It may be an error. Mostly we consider it as an error, right? So that is the reason we say it as missing completely at random. So at the end of the day, tomorrow when you're working in with respect to any data set, right, these three reasons will be there why some data is missing. Okay. Coming to the second time, missing at random, which is also called as MAR. Now, missing at random is a type of missing data mechanism in which the probability of value being missing depends only on the observed data, right? So it is basically dependent. Why that specific missing data is there, it is dependent on some other data. Probably in that specific column, in that specific field, or in that specific columns, there will be different columns. So because of that, there may be a missing data available in the other column also, right? So in other words, if the data is MAR, the missing values are systematically related to the observed data. There is some relationship. One example I can talk about, right? The basic example I'll talk about. Let's say if someone has given me to fill the survey and I'm not comfortable. Usually men are not comfortable to disclose the salary, right? Women are not comfortable to disclose the age, right? So this kind of survey, right, when we are probably filling, if there is an income field, I'll not fill. So you will be able to see that probably male are not filling the incomes, women are not filling the age, right? So here there is some relationship. So this is basically called as missing at random. You can definitely see both these examples which I have written over here. Okay. Now coming to the third type, missing data not at random. So here it is a type of missing data mechanism where the probability of missing value depends on the value of the missing data itself. Okay. In other words, if the data is MNAR, the missingness is not random and is dependent on observed or unmeasured factors that are associated with the missing values. Obviously, there is 3 liners that I have actually written, but it is better we probably try to see the definition. It is also saying over here that the missingness is because of some other reason, and there may be multiple factors also. Like here you can see, suppose you are collecting data on the income and job satisfaction of an employee in a company. If the employee who are less satisfied with the jobs, okay, are more likely to report the income. Let's say I'm not satisfied with my job, so I'll not put the income, right? So then the data is not missing at random. In this case, the missingness is dependent on job satisfaction. So it is basically dependent on multiple factors, right? So that is specifically called as missing data not at random. Okay. So these were the three types. Now what we are going to do is that we are obviously going to see some examples and how to handle all the missing data. There will be multiple techniques that I will probably show you. Okay. So first of all, let's go ahead and import Seaborn, because I'm going to use a data set. Let's say I'm going to use a data set which is called a load data set, right? Now inside this load data set, I'm going to use a data set which is called as Titanic data set. I hope everybody has seen a Titanic movie, right? Why I'm taking this? Because this data set has a lot of missing values. And for our problem statement, when we are discussing the three scenarios, we can come to a conclusion. At least two reasons can get satisfied from this. Okay. So let's go ahead and let's see df.head. This is there. If I want to check missing values, So for checking missing values, I can basically write df.isNull. Okay. So if I write isNull, so here you'll be seeing wherever there is a missing value, that will become true, and remaining all, wherever there is a value, that will become false. If I really want to see the sum, so I can probably see the sum. There is an error. So if I write dot sum, so here I'll be able to see this. This basically shows that in which column, how many null values are there. So here you can majorly see in H column, there are 177 data points that are having null values. And in DEC column, you have 688 data points which are having null values. And embarked town is also there. Embarked is also there. 2 are there. Okay. Now this is the data set over here. Age, embarked, DEC. DEC is just like a seat number if you have seen Titanic movie. Okay. So these are basically having the null values. Now, one easiest way of probably removing the missing values is that delete the rows or data points, right? Data points to handle missing value. But what is the problem with this? You will lose a huge amount of data. Right now, if I write df.shape and see, it is 891 data points are there. But now if I say df.fill NA, or sorry, not fill NA, drop NA. I'm just dropping it, right? And I'm dropping with respect to data points. Wherever there is a missing value, drop that entire data point. Now, if I go and see the shape, you'll be able to see that how much data points it will be left. Only 182. Before it was 891. Now I'm just having 182. So this dropping feature that we are specifically doing is bad because we are losing huge amount of data, right? Now, over here, we should definitely not go with this. Okay, it is not a very good idea to go with this, because unless or until you have a very huge data set. But right now, we had 891, but because of dropping all the NaN values, you have now 182, right? So this is a blunder. We should not do that. Okay. Now, can we do column wise? You may be thinking, can we do column wise, right? Because over here you can see each column is having 177 data points that are having null values. DEC is having 688. Now total number of data points are 891. So I can probably go and delete this DEC column. Yes, it is a suitable way because you have so many NaN values. But age, we cannot drop it as a column, right? But if you feel that, okay, if there are many data points that are having null value, in this case like DEC, you can delete that column, right? So column wise deletion. For this, we can write df.drop NA and just change the axis value to 1. So once you're able to do this, it will drop all the features that are having NaN value. So age and embark column, you can see over here, it is dropped, right? So you can probably also write in place is equal to true to make it a permanent operation, right? It is up to you. Right now, I'm not making it and I'm just trying to show you all the ways. Now, this way we can probably delete the rows, we can delete the column, but we will try to see some imputation techniques. Okay. We'll try to see some imputation techniques. Now, with respect to imputation techniques, just give me a second. So with respect to imputation techniques, I will just write a comment. Imputation techniques basically means how we can handle the missing values. So I will basically say imputation missing techniques, missing values, or I can basically write this as imputation missing values. And now I'll make this as a markdown. And first technique that I'm probably going to follow is basically called as mean value imputation, right? So mean value imputation is a technique which we will specifically be using over here. And with respect to mean value imputation, as the name suggests, mean value, that basically means we are going to replace the missing value with the mean of that specific column, right? Now, what I can do, obviously we have imported cbound, right? So I will write snh.distplot, and let's say I take an age column because it is a numerical column. And if I try to execute this, now here you'll be able to see that I'm probably able to get this specific diagram, right? Distplot. If I probably say histplot, and let me make my KDE is equal to true, right? So here you can see that this looks like a normal distribution somewhat, right? Not exactly a normal distribution, but it looks somewhat, right? Now, you know that in age, you have 177 data points, which is having null values, right? So can we handle this null values by replacing it with the help of mean value, right? So for that, what we can do is that we can just write df dot fill na, right? Df of age, okay? Df of age dot fill na. And in fill na, what I'm going to give, I'm going to basically give df of age dot mean. By this, I will be getting my mean. And let me just go ahead, and this mean is basically a function. So please make sure that you remember this. And I will save this in my age underscore median, right? So once I do this, you will be able to see now my df, okay, will be like we have created a new column, which is called as age underscore median. Just a second, median, comma age. Now, if I probably see this, you'll be able to see that the nan value will get replaced with mean, right? So over here, my age underscore median, here you can see in age, there is a nan, and this has got replaced by 29.699. Okay. This basically means that we have replaced the nan value with the mean of the age, right? Sorry, this should not be median. Sorry for that. It should be mean. Okay. I just wrote it by mistake. It should be mean. Okay. So apologies for those mistakes, but I think age underscore mean is not in index, not a worries. I will execute this, and now we will be having this. So here you can see that the nan value is getting replaced with the mean value. Okay. So I just named it as median, so don't get confused with that. So this way we can probably see mean. And when should we use this? We should definitely use this. This will work well. Mean imputation works well when we have a normally distributed data. Okay, normally distributed data, right? But what if, now the question rises, what if you have a different kind of distribution? You have a right skewed or left skewed. So for that case, you know that outliers will definitely be there. So you can replace the nan values with median, right? So for that, the second method that we are probably going to see is called as median imputation, median value imputation. Okay. I'm showing it in front of you guys, each and every techniques. So you can practice with any data set you want as such, right? So this is basically median value imputation. And why we are specifically using, if we have outliers in the data set, okay? So how to do this again? So what I will do, I will write df of age underscore median, okay? And then we will try to replace a df of age dot fill na, and I will try to replace this with df of age dot median, right? So once I do this, the execution happens. Now I can copy the same code and I can probably see this over here, right? And this will basically be my median, right? I can also go ahead and write about age underscore mean, comma age, right? So this is how my data set looks like. Here you can see nan value has been replaced by 29.666699, and this is 29.69918. Okay, but here let's see, I have taken df.age of median. Okay, sorry, I'd created a variable before also, right? Capital A. So here this nan value has been replaced with mean over here in this column, which is age underscore mean. Now, if I probably go and see age underscore median, it has been replaced by 28. So this will definitely work well if you have specific outliers as such. Okay. Now, similarly, you can use median. And now the third technique that we will probably go ahead with is basically called as mode imputation technique. Mode imputation technique. Okay. And this can be used with categorical variables. Okay. Categorical values. So I will show you an example over here. Now let's say that we have one column which is called as embarked. Okay. Embarked. And if I probably see is null. Okay. And probably what I will do is that I will just try to take out all the information which are having null, right? So here you can see in embarked column, you have two nan values. Okay. Now we'll try to handle this nan values. Now see, embarked is an example of missing completely at random, MCAR. If I probably say missing at random, there is some relationship, right? We can consider age also, right? We can consider age over here. Just a second, I'll show you. Age has been missing because see in Titanic, right, that boat had sank, right? And many people died and we could not capture because those people died. We could not capture the age, the seat number. So deck is also completely empty, right? So here you have a lot of missing values. So one or the other example, it will get related to, right? Now this example, there is no relationship at all. There's no relationship at all. So this can be actually belonging to the first technique, missing data completely at random. Okay. Now, in order to handle this, since this is a categorical variable, why I'm saying categorical variable? If I write df of embarked dot unique. So if I probably see unique function, I'll be getting these values like SCQ nan, right? Over here, you have this nan value, right? Now, what I need to do is that replace this nan with some of the values over here, categorical values, which I can probably find out through mode. Okay. So for that, how do I find out? So let's say I write df of df of embarked. So df of embarked, and there is a function which is called as not na. Now not na will give me all the output, which will basically be saying that wherever there is no nan values, okay, try to give that value as false and remaining all true. If there is a nan value, give me as false, not nan, right? Something like that. And if I want to get all the values which is not having nan also, I will be able to get it. I will just write like this, right? So these values here you'll be able to see in the embark column, right? Wherever there is nan value, right, that will all get skipped. Okay. Now through this, now what I'll do, I will take my embark column. So this will basically give my embark column, and then I can probably apply mode. Now here, if I'm applying mode, I get S. So let me take this value as my mode. Okay. So by 0, if I write index of 0, I'll get mode. So this is nothing but this is my mode value. Okay. Mode value. So I will store this. Now in order to replace over here, what I can do, I can write df of embarked dot fill na, and I will try to replace this with my mode value. That's it. Mode value. Now once I do this, I will save this over here in the form of df of embarked underscore mode, right? So this is my column name. I'm saving it over here. Now finally, you'll be able to see if I write df of with 2 square braces, and I want to display both the column that I have created. So here I'm just going to write embarked mode, comma, mode, embarked. Okay. So these two columns I'm going to see over here, and where there is nan value, that has been replaced by the mode value itself, right? So you can probably see it. If you don't believe me, just do like this: df of embarked mode dot is null dot sum. Okay. So if I write like this, so here you'll be able to see zero null values. And similarly, if I probably go and see with respect to embark, there will be 2 null values, right? Because there were 2 null values that got handled over here. So this way you can probably see this. There is also one more technique which is called as random sample imputation. In random sample imputation, you don't worry about anything. You select randomly any value from that particular column and replace the nan values, right? Now this way, what will happen is that this is basically this is called as random sampling technique. You probably select a random value, replace the missing values with that. Okay. And every time it can probably change. So I hope you got an idea with respect to how you can probably handle missing values. We wrote a lot of lines of code over here. We understood, we discussed about mean, median, mode. And there is also one more, random sampling. Just try to do that random sampling. What you do, just select a random value from the column and then replace that missing value with that. Okay. So yes, this was it from my side. I hope you like this particular video. I will see you all in the next video.